met jullie in het Engels doen, denk ik, because we have a guest from the UK. So we're going to be talking in English, even though we're called Software Developers Netherlands. So welcome. I will be talking to you about logging, instrumentation, dashboards, all the stuff that you need, in my opinion, to know about, as well as developers. So for you, I'm assuming you're all developers here, right? Yeah, cool. So you might think this is not for me, and I hope that when I'm done, you will change your mind and you think this is also for you and you need to know and want to know a little bit about this. But before I get to that, let me quickly introduce myself. My name is Henry Been. I'm a typical Dutch guy. Most interesting thing about me is that I live on Texel, which is, for our guest from the UK, the most western of the Waddeneilanden, the series of islands that go from the Netherlands to Awesome. So that means that I ferried in to what we call the mainland somewhere at the start of this week. I'm really happy to go home tomorrow evening again. And next to that, I'm an all-round nerd. I do I currently work at ING 3 days a week. I do consultancy, training. I create online trainings for a cloud guru, which is like Pluralsight, but a bit more cooler, in my opinion. So I enjoy that a lot as well. But you're here to talk about something else. And I think the essence of logging, instrumentation, dashboards, alerts, for me, is knowing, oh no, I'm going to do something else, it's really funny. I've given some thought to how to structure this talk, because it's going to be an hour. In a 45-minute talk you can just babble, but when it's an hour you need a structure, you need an agenda. So I came up with this agenda. I went over it with my wife. She says that I'm always so negative. And she thinks this reaffirms that statement, so she came up with this. But both of them don't really give you any insight into what I'm going to do, so this is what we're going to be talking about. I will start off with some theory surrounding monitoring, instrumentation, logging. Then we will talk a bit about what to monitor, and probably more fun about what not to monitor. And then we will get into some demos. Now, like I said, the talk is roughly 45 minutes, so that leaves 15 minutes to get this presentation into a discussion, and I hope that we can have a little bit of a talk about things you want to learn, things you want to see, and I will try to demo them on the spot. No pressure. Be kind. So monitoring. Monitoring is the topic I want to talk about. But what is monitoring, really? For me, it is knowing what be happening in production. This is the whole purpose of logging and instrumentation. It's not something you have to do, it's not a box you have to tick. It is about knowing what is happening in your production environment without hopefully logging into the portal, but getting things sent to you. And when I say happening, I don't really mean my service. I am not interested in CPU usage. I am not interested in page I/O. I am interested in, are my users happy? I think that's the main question that we should try to answer. And if the answer is no, we should try to answer the question, why aren't they happy? And what can we do? What new work can we start to change that? That's my take on this subject. Now to do that, we have 3 things that I want to share with you, and I'm going to demo them as well. All goods come in 3s. The first one is instrumentation. This regards what we call metrics. Metrics are things, values, that I can record about something at a certain point in time. For example, the temperature, or the amount of people in the room. These are metrics. Now what is interesting about these metrics, I can declare everything a metric, but I can also group metrics that talk about the same thing and give them a dimension. For example, temperature, I can record it for this room, I can record it for Lindenburg 2 and Lindenburg 3, and I can declare that 3 separate metrics. But I can also have one metric with a dimension location, and then record the temperature separately. But by that also get the means to really easily get the average temperature for all 3 rooms, or the room with the lowest temperature, or the room with the highest temperature. So those are dimensions. Another thing that we can do is record events. So not just the number of people in the room, but for example, somebody walks into the room, or somebody leaves the room. We can model those as metrics with a value of 1 and a timestamp. These are really interesting to observe for your systems as well. Now, of course, once we have a lot of recordings for a metric, we can draw a line. We'll call this a graph. Multiple graphs combined, we call a dashboard. So that's how metrics relates to dashboards. And metrics are also the basis for alerts, because once we have a graph, we can draw a line, we call it a threshold, and we can get a notification whenever a graph crosses that threshold. There we have alerts. Now, instrumentation is really valuable, but I think from the three things I'm going to show, the one that is most often forgotten by developers, instrumenting their code. And we'll see some examples later on. Another thing, this relates to logging, is tracing. Tracing is the art of emitting a lot of information from your code about what it is doing. I'm currently in this method entering. I'm currently in this method starting the for loop. I'm currently in this method doing the third iteration of the for loop. All these kind of information. Now, tracing is really system oriented. It tells you what the system is doing at a specific time. Maybe it's telling you why, but it's really related to the system. Now, this is often very verbose. It can generate lots and lots of information. So you're probably going to store it for forever. You're going to store it, for example, for 2 weeks. Then you're going to throw it out, maybe 4 weeks. And the reason is that the main reason you are collecting this is for troubleshooting. If you want to find out why something went wrong in your system, you're really diagnosing an issue, this information is going to help you. Now, of course, tracing can be a source of metrics as well. Simply the number of log entries per second or the number of warnings per second are metrics. And the third one is logging. And I think we developers are inclined to call this auditing. This is not, it's the same thing when it comes to the technique, the technical means, but it's really different when it comes to the goal we want to achieve. Here we want to record what we call state changes in the system that are interesting from a business point of view. For example, a customer placed this order. This was his identity. This was when he signed in. A customer paid. Things that you might need later on to explain to the customer why you delivered 522 pizzas to his grandmother. Or when you find out that you've been hacked 3 months ago, you can use these to find out what that hacker has done, hopefully. So this is really concerned with who did what and when and why was it allowed. Again, this can be a source of metrics, and if you're smart, and you are smart, you're going to retain this much longer than you're going to do with your tracing, probably indefinitely. Now, we want to add this to our applications, and let's assume those are .NET ASP core applications. Then you have to build up an architecture to emit these logs and metrics from both your application and the stack that it is running on, and gather them in some way to make them, to get them in a format you can work with. So let's assume we have an application instance, which can be whatever you want it to be, and that's running on an application host, a container, a virtual machine, an Azure App Service Function app, if you like that kind of stuff, Jan. Anything that can run your code. Now you're going to install two things. On your application host, you are going to install an agent. That agent is going to collect all the logs and the metrics of everything on the stack below your application code. So everything that's not managed by you, basically. And you're going to install an SDK inside your code, in your application, and you're going to use that SDK to emit logs and metrics from your application level. So two different things, emitting the same about different parts of the stack. Now, since this is 2019, we're going to send everything over HTTPS to another location. Sorry, my lenses. And from there on, we're going to pick it up and ingest it in a database. Now, for my logs, this is kind of a regular database, often designed for high-speed appending and really fast to search. Can cope with deletions at a high rate as well, but in general just a database. And everything is going to land there. And we can query that information. We can do the same for metrics. But metrics are a little bit different, because we're not going to store them in a regular database. we're going to store them in what is called a time series database. Time series databases are really optimized for recording metrics. Metrics are different than general purpose formats because they have this timestamp value thing that really sets them apart from regular other forms of data. And that means that you can optimize your database to cope with that type of data. One of the things, for example, a lot of time series databases support is a thing called rolling up the metrics. If I'm recording my CPU usage percentage every 10 milliseconds or every second, that will generate a lot of data. And if that data is only a couple of minutes or maybe a couple of hours old, that information can be really valuable to see how the load on my system is evolving. However, that same level of detail is not interesting anymore in 4 weeks or in 2 years. So what we can do is we can roll these metrics up, which means we're going to average all the values in 1 hour. We're going to throw out 60 data points and instead have just one for the whole hour. Maybe we're going to record the min, the max and the average, but that's it. And the older the data is the more we're going to roll it up. And that way we can keep the amount of information manageable. We still have the value of trends, things changing over time, and we do not have the non-valuable information of really detailed information anymore. So that's what a time series database can do. Now, time series you can also query. You can query them and get a table with results. But tables are really boring, so you're probably going to render them using a visualization engine as a chart. And if you combine multiple of those, you have a dashboard. Now, all of this is concerned with getting the data, ingesting it, and storing it for a period of time. But this does not do anything real time. So next to this cold path, we can add a hot path. So here we're going to use streaming data techniques, where we're not going to store all the data and then send a query to the data and have the results come back to us. Now we're going to make a system that lines up all the queries and have all the data flow in front of these queries, and each query will pick the information that it finds interesting or that it needs to answer the query it is responsible for, and whenever it has a result, it will emit that result. So the queries are stationary, data flows by, and when the data has gone through all the queries, it will be dropped on the floor, it will not be retained. So this is a completely separate path. And the terms hot and cold path come from, for example, ETL systems or big data approaches. Now we can do that for our time series, and we can also do that for log entries. So this is kind of a go-to default architecture for a lot of the approaches and implementations you can get for logging and instrumentation. We're going to be talking about Azure Monitor and Application Insights. They do this. But if you go to, I don't know, Datadog, for example, it will be more or less the same. Same goes for New Relic. They all kind of follow this architecture. At this point, you might not be really interested in what I've told you, because you think this is not for me, I'm a developer, and this is for operators, right? Why would I care? As always, there are two reasons, the bad reason and the good reason. So the bad reason is somebody once yelled DevOps and DevOps pays well, so I want to get on the DevOps hype wagon. So that is one thing. A better reason might be, yes, DevOps is a thing. Yes, DevOps adds value. And going back to the premises of DevOps, it's about developers and operators working closer together to together reach common shared organization goals instead of optimizing for team level goals that go against each other. Now, one of the things you need to properly work together is to have conversations. And it's much easier to have conversations when you at least know a little bit about what the other one is doing. So that's a good reason. And a third reason is, if you go back to this architecture, all the metrics and logs from the stack down are automatically gathered in Azure. But logs and metrics from your application, you have to write yourself as a developer. You have to emit logs and metrics. So you do need to know at least enough to make that happen. So that's why I believe you should care. So now you care, I hope. Now you're running into another question, which is more interesting, and that is, what should I monitor? What should I look at when it comes to metrics? I already gave you a little bit of a hint. CPU usage is not really interesting in my opinion. So let's turn that question around. Yes, this was the best joke that's going to be in here. What not to monitor? I think because there are some prime examples that will help you decide on what to monitor and what not. So let's go through an example. Oh no, let's go through this first. The first thing not to do is focusing on your systems. That's my opinion. And the reason is that your user does not care at all about, I don't know, the size of your page file or the number of disk IOs. Nobody gives a crap from your users. The other thing is, do not focus on averages. If you have 10 machines, the average CPU usage will probably always be 70%. But there are probably machines doing nothing, and there are probably machines being really, really highly utilized. So averages can be lying, cheating bastards. So do not stop by looking at averages. Also look at minimums, maximums, or percentiles, for example. Now, to add a little bit of nuance to this, of course system metrics can be interesting, because often they will be leading indicators. If you know that your disk can do 400 IOPS, and you see your IOPS slowly going from 370 to 375, trust me, probably in a couple of hours stuff will stop working. But it might not be the first thing to start monitoring. And the same goes for averages. They can be handy, but they're not always the answer. So, some examples. So as I have been working at a company that had 1 or 2 databases, or a bit more, and we had this pattern that the load on these databases was on average somewhere between 10 and 30%. The numbers are figured, but the use case is based on a real case world scenario. So what we observed was that all of a sudden for one of the databases, the load increased to roughly 100%, and operators called and said, Henry, we've got to scale up the database. And I said, why? They said, because we're using 100%, and that's bad. The user is having a bad experience. I said, what bad? We're finally using what we're paying for. This is all good and well. This is what we're paying for. Let's use it. But they said, well, it lasts for a minute or 2, 3. The user wants more performance. So instead of scaling up the database, we called the customer. And this is where the fun starts. So what actually happening was that this was a specific customer that had a typical database, or an atypical database, that under a specific report took a really long time to render. So whenever the user felt like coffee, he ran this report and went for coffee, because he had a reason, an excuse to wait. So my premises was that if we scaled up the database, made this operation really fast, the user would not be satisfied with us at all. For 2 reasons. He would not get his coffee, and we all know how people are without coffee. And secondly, he would have to pay more for not being able to get coffee. So this proposed alert for the operators to automatically scale the database up, in this case, did not make much sense. So the point that I'm trying to make is, if you only look at your systems and your system metrics, that does not really help you answer the question, are my users happy? So another example about averages is in this graph. Here we see the average response time for an API, somewhere around 100 milliseconds. A bit high, but maybe not problematic. So again the question, are my users happy? Don't know, because averages. So let's add the maximum response time for the same intervals. Again, these are made up numbers based on real case scenarios. Most of my users might be happy, but definitely some of them are not. Or if I, in this case, apply what we have learned about dimensions, and there is often a dimension called operation name. So for every URL you get a dimension. If I render it per dimension, we will get the blue line, which had the original average, an orange line, which shows how long it takes to view an item in my web shop, on average, and a gray line that shows how long it takes to add it to the cart. Here I am measuring something that really impacts my users and probably is limiting my conversion. If I have to wait for almost a second at a web shop to add something to my cart, I might be leaving that web shop and go somewhere else. So, percentiles. I'm not going to be spitting around the room shouting percentiles, but it fits the metrum, percentiles, percentiles. So that's one trick you can use to avoid such a situation. Point is, measure things the user cares about, because that's why you do all this. And think it through, because it's not as easy as you might think to really measure the impact on your users. So, enough babbling. Let's look at a quick example. I almost broke your microphone. So, I have a simple application that we're going to be talking about in more detail later on. But one of the things that this does is it has a producer that generates work and a consumer that fulfills the work and a queue in between them. So that's a pretty typical cloud pattern, I hope. Now, I want to monitor if all this is working perfectly for my users. Now, the go-to solution in such a scenario for a lot of operators would be to look at the number of messages on the queue. And if that number is really low, everything is fine. And if that number is really high, there might be something in the fan. Now, what if my system is doing 10,000 messages per second? What is my threshold? And what if at night my system is doing 4 messages per minute? What should be my threshold for alerting? And am I really measuring the impact on the user here? So the answer is no. Does anyone know a better way to measure the impact on the user of using queues?
I would guess the time it takes between the message being produced and the message being consumed.
Yes, that's the right thing to measure. Because if it takes like 20 seconds to do the processing, my queue might always be empty, but my users will probably not be satisfied. So if I look at another graph that I almost accidentally showed before, this is the average queue delay. So while the system is processing, I think, a couple of thousands of messages per minute, right now, the average delay is 1.5 seconds, which is too long for this system. Users will not be satisfied. And to also show you, again, with a real example, why averages are not necessarily the best thing to look at, go a little bit more to the right. This is the maximum queue delay. So there are some really rare spikes here. I know why they're there. That's because I added an exponential delay in the processing. It gives you this nice graph. But I hope this shows you how difficult it is to really measure how your users are experiencing your applications. Now, if you want to learn more about this, because some of the insights that I shared I have gotten over the last couple of years, but of course there were much smarter people who already knew all of this. They've written a book about it, or he has written a book about it. His name is Mike Julian. It's a really good book, really learn a lot from it. For those who don't like reading, it's also quite thin, so that's a plus side as well. True story. Now we get hopefully to the least boring part, and that is, how would I do this on Azure? So we've talked about monitoring, logging, some theory. We've talked about what to monitor when it comes to metrics, but how would you do it? So it's time for demo. Well, almost, yeah. I paid a lot of money for this picture, I think 1.5 years ago, so I just keep using it in every presentation wherever I can, and I think I keep making the same remark about it as well. So it's almost demo time, because I want to tell you a little bit about my amazing application, inspired by somebody who I know quite well. I have created a URL shortener, because that's a typical thing we all do every now and then. It has one function called URL shortener, which can receive a post of a URL and an alias. It can receive a get, then you have to provide alias, and then you get a redirect to the URL. Now this post does not save the alias directly in the database. It is going to put it on a queue. So this is my sign for a queue. I suck at PowerPoint. And then this processor is going to pick up that message and process it and add alias to the database. So that's my amazing application. Took me a couple of hours to write. Now I will talk you through how I monitor and log from this application, and I hope you will see all the elements of this architecture in that demo. And this is also the point where I hope that we can change this from a presentation to a discussion. So just shout and, well, not necessarily shout, but ask whatever you want to ask. So let's start with talking about metrics. Every service in Azure emits its own metrics. And these metrics are actually the basis of all the graphs that you see when you, for example, browse the portal. So what I can do, I can open up a random database and I can see this graph that's built in. Now I can click that graph, or I can go to the monitor tab for this resource, or metrics tab, sorry. Every resource in Azure has this. And every resource in Azure emits a series of metrics that you can use. Oh no! Any questions? I think this relates. I can make it go black. I think this relates to zoom it. Okay, no, then we'll use this this tool. So there are a lot of metrics that I now cannot scroll because that view breaks up the screen. There are a lot of metrics that are emitted by any service. For example, this is a SQL database. This emits the percentage of DTU used, the number of connections, the number of field authentications, all the things that you might be interested in about this database. So let's just pick one. I don't know, DTU percentage. And we're going to use the average. Why not? And I can add a second metric to the same graph. And again, let's go for DTU percentage, but now the max. Now, here we see there's a little bit of a gap, but nothing really disturbing. This way, I can build graphs in Azure from any out-of-the-box metric. Now, if I go a little bit back to the selector, you see that I've now worked with this one to pick the metric, and pick the aggregation, the two in front as well. Here I have to pick the resource, which is now pre-selected, because I am navigating from a resource to its metrics. And I have to select the namespace that I want to pull the metrics from. Now, every resource in Azure by default has one metrics namespace, so that's also pre-selected. Only when you start working with your custom metrics from your application code, you will get multiple namespaces. We will see that later on. Now, once I have created a graph like this, as you already can see here at the top, I got a button pin to dashboard. Also, by the way, a new alert rule that we will see later on. Now what I can do, I can pin this to my currently selected dashboard or to any dashboard that I already have in Azure. So let's just do that and create a new one just because we can. We call it new dashboard. We put it in West Europe because we don't want the CIA taking a look at this. And there we go. Now a new dashboard is created and this first graph is added to it. So if I go back to where I was, because there I have a little bit more interesting dashboard, you can see that this way you can really quickly and easily build dashboards from metrics that are automatically collected. And also from your own metrics, by the way, which I will show you later on how to gather. Now there are a number of things that you can do with a dashboard. A dashboard has a window of time that it shows, so currently 24 hours. And I can, for example, change that to the past hour. All the graphs will change along with that. I can also add filters. I can say I am only interested in operations for my load generator. And there we go. And then my dashboard will change according to these settings. If I refresh, all these changes are revoked. Now these dashboards you build only for yourself until you share them with others. So here at the top, you can see there's a button unshare because this is already a shared dashboard. When you start sharing a dashboard, it becomes a default Azure resource like anything else, and it is hosted in a resource group, just like anything else. Role-based access control is enabled. You can even govern it with Azure policy. It is a resource like any other. So those are dashboards. Let's open up a graph again and take a look at alerts. I don't even know which graph did I pick. This is the average delay in processing of a message. So okay, that's a fun graph. Let's change that to the maximum. Oh, here's a bug. I have to switch this, then I can go to max. Let's start creating an alert rule, because I love being called at night whenever adding something takes longer than 3 seconds. So when I go through the experience for adding a new alert rule, the first thing I have to do is selecting a resource. So this is a really cumbersome picker. I would not use it if I were you. Just go to a resource, go to the proper graph, and then select Add Alert Rule. And once I have selected the resource I want to create an alert rule for, I have to specify an alert condition. So there is one selected, or half built for me already. It's because I already had a metric selected as well. So I get the graph for that metric. And now I can start building a rule that says when the maximum is greater than 5,000, this alert should fire. I can also switch to a thing called dynamic thresholds, which is still in preview. And here it will automatically change the threshold depending on the current value of the metric. So for example, at night, the threshold might lower, and during the day the threshold might increase. Not necessarily the thing you want, but it's possible. But let's stick with a static threshold. Now another thing that I can do is determine the interval over which this maximum or average or whatsoever is calculated. So that's the granularity of the calculation. So let's set that to 15 minutes. And next I can set how often Azure should evaluate this alert. So if I set this to 1 minute, the second the maximum is over 5,000 in a 15-minute period, I will be notified within the minute. Plus a little bit of latency, which is guaranteed to be lower than 1 minute as well. So within 2 minutes. Now since I'm using the max here, I can set this to 1 minute as well. Now you can add multiple conditions if you want, but we're not going to here. Now so I've selected the resource, I've selected the metric, I've selected the threshold, but I haven't selected what Azure should do whenever the threshold is met. So to do that, I can add one or more actions. Well, not necessarily. I can what are called action groups, because I will probably create tens or hundreds of alert rules, and I do not want to type the email address or the phone number of the CEO in every alert rule. Especially since he will probably change his phone number after the first couple of text messages at night, I have to go revisit hundreds of rules to change that phone number again. So instead I can create what are called action groups. They have a name and a series of actions to perform, and I can reuse that action group for a lot of rules. Now I already have one, but let's create a new one just to see what it looks like. It has a scope, so a thing that it's located in, and this is completely the wrong thing, sorry. New alert rule, thank you. Add, sorry, these are action rules. Hey, this is new. I was looking for action groups, and you used to be able to create a new action group on the fly here, but you can't anymore. I will show you later on how to do that. So now I have added an action group here, and this action group will be called into whenever my alert fires. Sorry?
There's a button there, add action group on top.
Oh, there it is now. You're right. And this is add an existing action group. This is not create a new action group on the fly. That was what I was looking for. So this is how I set an alert rule. Let's not do this because I do not want to get cold at night. So we have seen everything when it comes to instrumentation from the stack of our application code down. Let's take a look at how we can start emitting metrics from our own code. And for that I'm going to open my tool of choice, Visual Studio. So I'm not into code yet. there is a class called telemetry client, which is part of the application insights package, NuGet package that you can install in your application. This class you can new up wherever you want in your code. Here I'm injecting it through dependency injection. And the instances of this class have a method called getMetric. Sorry, let's satisfy my OCD. That have a method called getMetric that allows you to get the name of a metric and one or more dimensions. So method usage, that's the metric. Method is the name of a dimension. And then track a value. Now I have emitted my own metric. This is how straightforward it is. Now you might be wondering, how does it know where to send this? So to do that, to send it somewhere, I have to create what is called an application insights workspace. And that workspace is going to provide me with what is called an instrumentation key. And this key is the connection between my application code and the place where the metrics are going to land. So this instrumentation key I can specify in my app settings and is automatically picked up by the application insights SDK. I don't have to do anything for that to happen. So let's switch back to the portal and see how this application insights thing looks. So I already have a namespace, it's called HB Application Insights. And the first thing you see here is this instrumentation key that I talked about. Is there anyone with a photographic memory in the room? Awesome, because then I can reuse this install tomorrow. Now an application, I have to do this talk again tomorrow. So this application insights workspace is the place where we can send our own logs and metrics. So this is the container, so to speak. So what I can do is I can go to metrics again. My resource is pre-selected. But now I have multiple namespaces that I can choose from. One of them being Azure.Application Insights. And when I pick this one, I get a list of all the custom metrics that are emitted by my application. And one of them, for example, is the add alias processing delay. This is a metric that's coming from my own application code. And I'm actually calculating this value indeed whenever I'm done processing a message, and I take the time it was queued and I subtract that from the time, the current date time, and the interval between it is the delay. For the rest, working with custom metrics is precisely the same as working with out-of-the-box metrics. Really neat. Any questions so far or any comments about metrics, dashboards, alerts, phoning your CEO? No one? I hope so. So let's, we have some time. Let's take a little bit of side tour. Let's go, because all these metrics tabs that you see. Oh, yes, sure, go ahead.
A couple of things I've seen, or a couple of times I've seen things, is where apps or systems are hitting buttons because they've got the wrong SKU that we purchased. When you go into Azure and you buy a service or a product, you have the different levels, and hidden away on the commercials bit of Azure, it gives you all the limitations on those service SKUs. So if you deploy a virtual machine and you think, oh, I'll just have a normal disk, or I'll do it to a particular standard SSD or a premium SSD, they actually have different throughputs and different loads that they will accept. So sometimes you need to be keeping an eye on what's happening to work out whether you've got the right product inside your deployment. Because you don't have to recode, you just have to change the SKU. And then your queue or your buffer or your problem goes away. Particularly if you're using infrastructure as a service VMs, it's the NTFS driver inside the VM is the same NTFS driver as you have on a normal machine. They've never fixed the throughput problem. If you set up a RAID 0 array on a hard drive subsystem in Azure, you would think RAID 0, no fault tolerance. But Azure Storage gives you 3 copies and a latent copy So you get fault tolerance, that then gives you 3, 4, 5 write pipelines to your NTFS. You can actually get a much bigger kick if you're doing a lot of logging to a local drive system inside of VM by actually setting up a RAID 0 array and pointing it to multiple storage groups.
Mm-hmm.
So there's all tweaks you can do when you see these things bouncing.
Yes, definitely.
To do with your app, it's to do with what you bought.
So for the recording, a lot of services in Azure you buy like a guaranteed capacity. They guarantee you get the capacity, but trust me, they also guarantee you don't get anything more than that, and you will get capped, right? So one of the things that might be interesting to monitor about your systems is if you are if you're close to this limit. So if I go back to the dashboard I showed you before, if Azure permits me to do so, one of the graphs that I draw here is because I do know Azure SQL a little bit, and there are a number of things that are kept: the number of sessions, the number of connections, and your DTU usage. And I'm graphing those three here together in one graph, and I can set alerts on that. Now trust me, my user experience will also deteriorate when I do not measure this, but only my average response time. I will get notified when this starts hitting the ceiling. However, this can be great leading indicators of failure to be in an hour. And leading indicators are great in the sense that they can help me to avoid disaster, right? So there's definitely value there. Anything else? Otherwise we'll get to logs. Okay. Let's talk about logs. So when it comes from, let's start in this case from our application code and up. Let's see if it's hard, or at least what is required to start emitting logs from my application code. Now, I think everybody is familiar with ASP.NET Core and the iLogger interface. This is, yes, if not, please say so, because I can definitely spend 30 seconds. The iLogger interface I'm adding here through dependency injection into a class as well. And I'm using it as you would expect. I'm emitting a log message. This is not an error. I do not want to use string interpolation. I do want to send a string with a placeholder and the value for the placeholder. This is called structured logging. I'm sending both a text message and a property back for all the values that are between the curly braces. Now this goes through the default things in ASP.NET Core, but I gotta pick that up somewhere and send it to Application Insights. So what I'm doing here, this is a normal dependency injection configuration as you would use for a Azure Functions v2 app. It's kind of the same as you would do for ASP.NET Core. Now I am adding Application Insights telemetry. This registers the telemetry client we saw before. And I'm calling into add logging, and I'm adding Application Insights. That's all to get it working, but that way you will only get warnings and up. And I am a sucker for more logging, so what I'm doing is I am adding 2 extra filters to this. The first one is for every log scope that starts with Microsoft, basically every namespace for a class that starts with Microsoft. And for that I'm only going to log warning and up. But for everything that starts with training, because that's my root namespace in this application, I'm going to emit information and up. And if I feel like it, I could change that to trace. So I can specify per namespace the amount of logging that I want to see. And this namespace is derived from the generic type that you specify to the iLogger, right? The instrumentation key is automatically picked up, and that is all that I need to do in my application code to send the data to Application Insights. And once it is in Application Insights, I can find it again. Do I have it open here? No. So let's go back to Application Insights. And now go to a thing called search. Logs will be a much more convenient name, but it's called search. So let's see all my log entries for the last 24 hours. 1.7 million in total. And there are different types Because I'm not really just collecting my logs here, I'm collecting a lot of events here. I'm collecting my traces, so these are my log entries. I'm also collecting every request, every page view, custom events, exceptions, dependency calls, so when I'm calling into other HTTP servers or into, I don't know, a SQL database or Cosmos DB, whatever, and availability. Now, let's filter this down to only my traces, so I can see only my log entries. And here I can see my log entries as I am emitting them from my application. Now, I hope you're interested in seeing how quickly I can search this. This is how quickly I can search through millions and millions of log entries. If I open one up, I will get all the fancy things that you might expect from a tool like this. I see all the events related to the same operation, HTTP call. I can see things that have been happening just before or after the thing that I clicked on. All the nitty-gritty details. Now, if you think this is not rich enough, and you're a real nerd, you're going to click on Log Analytics, and then you can query them by hand. So here I can do things like this, or say, give me all exceptions. And while that's running, let's change our mind and say I want to order them by timestamp descending. I want to take just 20 and rerun that query. Here you can write any kind of query you want. The query language is called KQL, Kusto Query Language, to query your logs. It's pretty awesome. Any questions? Now, this has one big drawback. It takes roughly 5 minutes for a log entry to be emitted, between being emitted from your application to being visible here. That's the way Application Insight works. It's gathering a lot of data and then it will ingest it in bulk. Makes it really performant, but also makes this 5-minute lag. Now this is really, that doesn't really matter if you're running an application in production and you want to do some troubleshooting after the fact. But it's really annoying when you're debugging an application that's running on a test environment and you want to quickly see if a change works, or even worse when you're running locally. So I am using another approach for running locally, and I promised some people that I will use the whiteboard, and I will do so now. So, yeah, that works. I drew my application code where I can install an SDK, and next to that I have an agent, and they are both running on an application container, right? Now what I can do is I can pick this SDK up and replace it with one SDK that can just call another SDK, or maybe another SDK. I can extend the architecture that was directly calling HTTPS to have like a in-memory logging pipeline, for example using NLog or Serilog if you're more into Serilog, and use that to have multiple streams of logs going out of my application. And one of those streams I can, for example, send to Application Insights. And the second one I can send to the local file system. And the third one I can send to a completely different system, for example, SEC. So I thought I would show you this in code as well, because SEC has a 0-second latency when ingesting logs. It's not that high performant as Application Insights. On the other hand, it's free if you run it only on your local computer as a developer. So what I've done, I have added NLog to my application, and I've configured NLog to send to Application Insights when it's running in the cloud. When it's running locally, it's going to send to SEC. Also, if you want to combine technically audit logging and trace logging, you want to make sure that everything that's emitted and necessary for your auditing, that it's really saved. So with NLog you can, for example, send 1/2 to Application Insight A, and 1/2, so this is your auditing, you can have to send to Application Insights B. And for logging, these are tremendous amounts of data. So here you probably, at scale, wanted to apply a thing called sampling, which means that not every log entry is saved, but only, for example, 10%. That is enough to gain insight in how your application is running in production. Application Insights will, of course, take care of sampling the things that have the exceptions that take the longest and not just at random. But sampling does not work together with auditing. If you want to audit, you need really everything. So you could use a separate application instance where you don't apply sampling and have NLog route between the lot of them. Can everybody follow along? Cool. Because it's not as complicated as it sounds, I hope. Here I have set up a really specific dependency injection configuration for myself. And I am configuring monitoring, which is as simple as registering the telemetry client by hand. And I am setting up my configuration for logging. Now here I'm doing something NLog specific, which means that I'm going to declare a target that I want to forward my logs to. Now, if usesec is configured, I'm going to new that up to be a sec target, which is running on my local machine. I can add some extra properties just for the fun of it. And I wrap that in a buffer, which flushes the logs every 2.5 seconds. Because if I really do them one by one, that's too much for my hard disk. And if it is not the case, I'm going to new up an application insights target and send everything over there. I add that to the NLog configuration. Then I configure my rules, which are called filters if you're using the built-in iLogger logging system. And then I register the NLog implementation of iLogger and the implementation of iLogger factory, and I'm done. Here I can easily add a third NLog target, for example, to save everything to the local file system, if I thought that to be appropriate. And if I were to run this application locally, and I pick up, that's fun. I did that yesterday as well, when I ran this dry. Okay, this will take a couple of minutes, especially in the connection here. So let's skip that for now. So that's basically the things I wanted to show you. Are there any other things you'd like to see? Questions you have? Remarks? Nothing? So in that case, I will be wrapping up. So one great presenter always had one more thing to share. So I hope to be a successor and have 2 more things to share. The first one being that the demo that I showed you of this URL shortener application is on my GitHub account, github.com/henrybeen. There's an ARM template that puts everything in place for the application, all the monitoring stuff, the logging stuff. Windows is nowadays multi-desktop, but apparently it cannot keep itself to its own promises. And then you can do a right-click publish from the code and deploy the code to the app service that has already been created, and everything will start running. Your metrics will be emitted, the graphs that will show up, etc. The demo resets itself every 4 hours, so if you have the money, you can keep it running indefinitely. Secondly, like I already mentioned, dashboards are Azure resources. Alerts are Azure resources. Alert groups are Azure resources. They are all Azure resources, which means that they are governed by resource providers, which means that you can put them into ARM templates, which means that your complete infrastructure for instrumentation, for metric gathering, reporting, and alerting can be delivered as part of your infrastructure using ARM templates. So if you're already using ARM templates to deploy your code, this is really awesome. This is also in the example on my GitHub account. Now let's hope Visual Studio has unfrozen already. Yes, it has. So let's open up my Solution Explorer. This is the ARM template for this demo. It is, I think, 1700 lines long. That is because there is a complete dashboard in this ARM template. So this dashboard is 700 lines of code. And as you can see, it's an Azure resource like any other. Really amazing. Any other questions? Guess not. So with that, thank you for your time and attention. Do try this at home. I will be sticking around for another half hour, then unfortunately I have to leave. So please find me out if you have any questions, anything else. And do find me on Twitter or LinkedIn if anything else. Thank you for your time.